Okay, so test is tomorrow, unit 7. Remember that for unit tests, you do not get to use your notes. So if you're working on the study guide and you realize like, hey, I really don't know the steps for completing the square and you have to look it up, just know that you would have to have that memorized by tomorrow. And honestly, I feel like that's pretty easy to do. Go through the study guide, anything that you have to look up, commit to memorizing that stuff. Make a flashcard, do something. But that is your responsibility. The only thing I'm providing you tomorrow is what? The quadratic formula. Yes, you can go to the table. So yeah, that's your responsibility to know everything else, though, how to do each method. And there's questions relating to every method, so that's why you have to know all of them. What questions do we still have on either portion of the study guide? Okay, starting with the eliminate one, number 8, was the request. Okay, so this one's a good one. You need to completely factor it. So think about that flow chart from when we went over factoring. So there's a few different methods for factoring as well. What was always the first thing we needed to look for? So at the very top of our flow chart was always I can't quite hear you guys. What is it? GCF is what you always look for first. There is not always a GCF, but if there is one, you do have to factor it out. Because if you just went straight to diamond method, you would not have gotten the right answer. So, is there a GCF between 6, 21, and 15? Sounds like we're not really sure. 3 is the GCF. Yes. So in other words, think of the biggest number that can divide evenly into all of them. Usually check the smallest one because it can never be bigger than the smallest one. 6 doesn't divide evenly into 21 or 15. So see if you can break 6 down further. All right, and 3 goes evenly into all of them. So when you have a GCF, where does it go? What did they type it? Off to the side. Off to the side. Right. So outside parentheses is what I'm looking for. And then inside is what you get from dividing each term by the GCF. Now on the study guide, you can tell from just that step alone what your answer is going to be. What's my answer going to be on this one? B, that's the only one that has a GCF and it's very identified. On your test, you'll have 2 answers that have the correct GCF identified. So we're going to continue with the rest of the steps, but that's the first one. Identify GCF, factor it out. What's 6x squared divided by 3? 2x squared, good. 21x divided by 3. And 15 divided by 3. And then you see if you can factor the parentheses further, which usually you can. So after checking for GCF, what do you look at next? So it's okay if right now you need to look at your flow chart, but just know you have to have it memorized for tomorrow. So after GCF, you look at number of terms. Is this going to be a 2-term or a 3-term? 3-term, and you don't include your GCF as a number of terms. That'll just stay in your answer in the same spot. What's the only way we know how to factor a 3-term? Is by diamond method. So only the parentheses is what you're looking at for your diamond. Notice that A is not 1, it's 2, so you'll have to divide the 2 out later. But what's my A times C? Don't tell me. Table 1, what's my A times C? is. That'll go on top. What will go on the bottom, table 2? 7. What are two numbers that multiply to 10 that add to 7? 5 and 2. So GCF still lives out there. Right now, this is what my parentheses are. But notice if I FOIL these, I don't get 2x squared, I just get x squared. So that's why you have to divide by a from your factors. My a was what? Just 2. So divide each factor by your a. 2 over 2 cancels to 1, so that one's just gonna be x plus 1 there. Is the 5 over 2, does that reduce anymore? It doesn't, so you slide any remaining denominators in front of the variable. Don't forget, GCF just lives there in the same spot, but that would be fully factored, and that matches B. And I know we already said we knew it was B on this one. The reason why we went through all the steps was because on your real test, you'll have 2 answers with the correct GCF. So that's why you need to know the rest of it. Questions on that? And now when I FOIL, I do get 2x squared, plus 2x plus 5x plus 5. I do get it. Questions on this one? Questions on others? Michael T? Oh, number 4. And then remind me, Tyson, again about that other figure. All right, so number 4. So quadratic function shown below. What's the value of the positive 0 of this function? This one doesn't specify that you have to use a certain method. So what method would you use? Okay, I think I heard someone say graphing. Anyone oppose? All right, I would agree. Graphing is pretty straightforward. You just have to know 1, how to type it in, and 2, where to look on your graph. So it's negative 5x squared minus 25x plus 180 All right, so type it in like that. Where on the graph do I look for my solution? The x intercept. And the question asked for the positive 0. Which one is my positive 0? Good. 4. So then it doesn't want the negative 0. It doesn't want the negative sign. It only wants the positive 1. So just from that, pretty easy. I think so, at least. Then your answer is 4. Questions? All right, others from either portion. Hayden, on this one? All right, so find all zeros in the equation. And you will type both of them into the answer box. So for this one, what method do you think would be easiest? What'd you say, Devin? Greatest common factor, so factoring. Yeah. I would agree this one is pretty easy to solve by factoring. So reason why it's already set equal to 0. It's a trinomial where a equals 1. So this one you could just do the diamond method and not have to divide by a. This a is already 1. What's my a times c in this one? Table 4, can you tell me? Negative 30, good. 1 times negative 30. Table 5, what's my b? And I'm looking for 2 numbers that multiply to negative 30, but add to negative what class? I don't think there's a way that I can play around with the 10 or 30 to make it add to a negative 1. Oh, so try again. What else multiplies to 30? I think 6 and 5 could work somehow. Which one would have to be negative? the 6. If it adds to a negative, the negative needs to be on the bigger number. But don't go ahead and type in -6 and 5 into your answer box, because it's asking for the zeros. So this is what it looks like factored. Now you have to think, what can I plug into here to make it equal to 0? What -6 equals 0? And then what plus 5 equals 0? So these two are my zeros, 6 and -5. So there's a difference. When it wants you just the factor, then you stop there at the red. When it wants the zeros, it wants what x has to be to make it 0. Questions on that? And how can you check your answer? I does not. Type it in. And everything on the test can be checked with dead zone. You just might not know how, you should figure it out tonight. So everything on the test can be checked with dead zone. So -5, same thing we got, and +10. Questions on this? Questions on others? Gavin? Number 10. On the study guide. So if you guys don't have this turned in, I have no clue why. Like, almost $3. Yes. Yeah. So number 10 on the study guide, we're finding the zeros. Well, Henry is finding the zeros, and his first step is shown below. Based on his first step, how do you think he's solving it? So more than one person I need to hear. If he went from this to that, what method do you think he's using to solve it? Oh, boil. Factoring. Oh. Boiling is when you go from this to standard form. Okay, so if you're going from standard the other way around to factored form, you're factoring. So if you think about your steps for factoring, I would argue that there's more steps before you just go straight to that one. But you want to first make sure it's set equal to 0, and then, go through that flow chart in your head. Henry already did that. He got to here. For his next step, let's go through these. Does he need to evaluate the standard form when x equals 0? No, that sounds more like what he should have done before that step that he already has, or if he was doing quadratic formula. So not in this one. That would be like going backwards. Does he need to set the 3x minus 2 equal to 2x plus 5? No, we've not done that. We've never set the factors equal to each other, so no. Does he need to evaluate 3x minus 2 and 2x plus 5 when x equals 0? Yes, no, maybe so. Maybe. Well, let's see what happens if we made the x to 0. If that helps me at all. So 3 times 0 minus 2. And 2 times 0 plus 5. What's 3 times 0? 0. And then minus 2. -2. 2 times 0 plus 5. Is this helping me solve for my zeros? No, this is like something random. That's like, I don't know what that is, but it's not solving for the zero. All right, what about the last one? I mean, it would have to be, because that's the only one left, but right, 2x or 3x minus 2 equals 0 and 2x plus 5 equals 0, and solve for x. Does that one sound good? All right, yes. Because after you factor to solve for the zeros, kind of like we did in the last problem, you set each factor equal to 0 and solve for x. This one's a two-stepper, but still you need to isolate the x. So what's farther, the 3 or the 2? Opposite of minusing 2. So if you go on one side of the equal sign, so I get 3x equals 2, opposite of multiplying by 3. dividing. So one of my zeros is 2/3. And then the other one I get from solving that one, which I think if I remember was -5. All right, just so you know, that's how you solve for the zeros. Questions on this one? Questions on others? Michael T? Number 3. Okay, so Angelo wants to graph the quadratic function shown. At what point does the graph of the function intersect the x-axis? So what would probably be the best method to solve? What was that? Probably by graphing it. He solved it by graphing. So why not do it the same way? I would not recommend completing the square. One, because the a is not 1, so you never learn how to do it like that. Would not recommend it by factoring, so it's a fraction. Quadratic formula you could probably do, but again, there's a fraction, so that makes it less fun for you probably. So graphing would have to be the best way. So 1/3 x squared. So 1 division sign 3 minus 2x minus 9. All right, so type it in just like that. And it wants to know where it crosses the x-axis. So in other words, what my solutions are. Does that match one of the answer options? Yeah. The only way I think that they would try and confuse you is writing it out of order. That's another way I feel like they could try and confuse you. But on the study guide, they didn't try to confuse you that way. So just check it in Desmos. If it's written in coordinate form, remember that x goes first. And that at the x-axis, your y's should always be 0. So that one best matches B, right? Yeah. Questions on this? Questions on others, Jorge? On this one? So the method of completing the square can be used to transform this equation into the form x minus p in parentheses squared equals q. So this is why we even bother to teach you the other methods, even though not all of them are ideal in every single situation. This matches the format of a step in completing the square. So you'll have to solve this at least part of the way by completing the square. That is in your notes. If you need to look it up, please do, but have them memorized by tomorrow. So for completing the square, what's the first step?
Divide b by 2 and square it.
I think that's not the first step. For completing the square, does it want it in standard form like this? Equal to what?
B.
It wants it equal to C, if you remember. If you don't believe me, look at your notes. Like lesson 12 or 13. But for completing the square, it wants you to rewrite it as x squared plus bx equals c. So how can I make it into that format? -4. Whatever you do on one side of the equal sign. So then from what I have x squared minus 8x equals 0 minus 4, which is -4. Does that look like the step it wants me to stop at? So then you have to keep going. Other than Tyson, what is step 2? So look it up if you need to, but have it memorized for tomorrow. You don't factor it at this step. Take a gander at our notes then. That was lesson 13 or 12. We wrote the steps down in both. Completing the square. Here they are. So after rewriting it, Step 2 says to take half of b, square it, then add it to both sides. So what's my b in this one? Don't tell me. Table 9, what's my b? -8. Class, what's half of -8? And then what's -4 squared? 16. So 16, we are going to add to both sides. Why, you might ask? Well, we went in depth during the lesson 12 lesson, why that works that way. Really in short, it's because it's the set. Half of b squared, add to both sides. What that does is make a perfect square trinomial on the left side. Notice these aren't like terms, so write it like this. On the right, what's -4 plus 16? 12. So right here, right, we have half of b, square it, then add to both sides if you're writing steps. Step 3 is to do what now? Diamond method for the left side. We want to factor that perfect square trinomial because then we can write it in this format, which it wants me to stop at. So if it's a trinomial, use the diamond method. Since it's a perfect square trinomial, it should be the same number that fits here and here. So what multiplies to 16 that adds to -8? Negative what? So should it be a perfect square trinomial? And what I've noticed is it always ends up being whatever half of b is in this method. So yeah, then you write it as a square. So as x minus 4 in parentheses squared equal to 12. Now, does that look like the step that it told us to stop at? You have to uncover your eyes to know. So does that look like the step that it wants us to stop at? Or do you want to keep going? You want to solve the whole thing? It does look like it, does it not? Is there a parentheses, an x, a minus, and then a number? So then, yeah, it looks like it. Look, we can't even say what if they look alike. Like, come on, get it together. We're testing tomorrow. So in that case, what number is in the P position? And what number is in the Q position? So then it's a +4 that you're plugging in. Because in the formula, it already has the minus. And then it's a +12. So it should match that answer. If it says -4 and +12, that's because you probably started it before the typo was fixed. So once you submit it and try again, you'll see the way that it should be. And it'll match that way on your test. Questions on this one? Questions on others from either portion? Okay, so projectile motion problems, anytime they're kicking, throwing something. Pretty much sums it all up. Dropping something from a certain height. It usually follows this path, at least part of the way. So in this one, they're kicking a kickball. And it has this equation to represent it. Height is h, t is seconds. And it wants to know how long does it take for the kickball to hit the ground. So a few different ways you could solve this. Which way do you want to solve it? That you think would be the easiest, most time effective? Gavin? Graphing it. I would agree, graphing it would probably be easiest. In the lesson, we practice quadratic formula, which you can do, but I do think graphing would probably be easiest. You just have to know that t is in the position of what letter usually? Where the x would go. So you just have to replace the t's with x's if you're typing it in. So negative 16x squared. Or plus, I think, 45x plus 24. So I would not recommend, what do you call it? I would not recommend factoring because these numbers are kind of big. Would not recommend completing the square for the same reason. Quadratic formula could work, or graphing. Where would I need to look for when it hits the ground? What part of my graph? The x-axis would be my ground, because what equals 0 at my x-axis? The y, which in this case is my height, which makes sense. If it's on the ground, my height is 0. So notice we have two x-intercepts. Desmos lets you click on them. There can only be one answer. So which one makes the most sense? The second one, because it is, and I cannot have a negative time. So that should match one of my answers. Which one does it best match? The fourth one. And that would be the only time on the test that you should round. Everything else should either be in radical form or something along those lines. Good? All right. Any other questions? John? On this one? Okay, so we have an equation can be solved by factoring and setting each factor equal to 0. What needs to happen before this can be solved? So steps for factoring. Looking at how it's set up, can it be solved the way that it is right now? What we need to change? You need to set one side equal to 0. Doesn't matter what side? It doesn't matter. One side would probably be easier. So I'd say move the side with the fewest number of terms. So I move everything to the left then. How do I move an x squared? How do you make it cancel? But I want the whole x squared to go away, not just the 2. Subtract it, whatever you do on one side. And notice I'm lining it up with the 4x squared, because those be like terms. And then how do I cancel the 5x? Subtracting it. Right, you do on one side of the equal sign. Do to the other. Notice I combined it with this like term. So it's 4x squared minus x squared. 4x squared minus x squared. 4. 3x squared. So when you combine like terms, you only change the coefficient, not the variable part at all. What's negative 2x minus 5x? Negative 7x. The 15 doesn't have a like term, but now it's equal to 0. Now you could continue solving. But this one just wants to know what needs to happen before it can be factored and solved. So, process of elimination. All x squared values must be moved to the left, and all other values must be moved to the right. Yes or no? No. The first part sounds like it could be true, but you have to keep reading. The rest of it is wrong. Did we square root both sides? No. Did we divide both sides by 4? So it must be this one then. But it says the monomials x squared and 5x must each be subtracted from both sides of the equation. Is that what we did? So that's why it's that one. Good. And then Tyson had asked for this one, so I'm gonna go to that one. It's the one on your constructed response. Because that's also due to, and that's like the key points in the stuff. What part was it, Tyson? Number 3. Number 3. So number 3 on your constructed response. We've not done one like this, but I think it's easy enough to figure out. Stop talking. So we have a community theater uses this function to model the profit in dollars expected in a weekend when the tickets to a comedy show are priced at $8 each. We need to write and solve an equation to find the prices at which the theater would earn $2,000 in profit. So what is the profit, the P or the D? P, so I'm gonna replace that part of it with 2,000. Equals to -5D squared plus 395D minus 800. And solve for my zeros. So there should be two answers, by the way. The two answers will both make sense. Depending on how you want to solve it, it's up to you. What way would you guys solve this one? I would not recommend factoring because the numbers are kind of too big. Would not recommend completing the square because factoring is a part of that, so I would not recommend that. So really, you're between quadratic formula and graphing. Okay, if it's quadratic formula, what does it have to be equal to? How can I make 2,000 zero? Whatever you do on one side, do to the other. And combine like terms. What's -800 minus 2,000? -2,800. And if you're solving it with quadratic formula, A is what class? -5, B is what? And C is -2,800. Hopefully you can from there plug it in. For part B, note that that says maximum profit and maximum like ticket price. So I would recommend solving that one by graphing. It's not really related to part A. So for that one, you'd use the original equation and figure that out. For your study guide, did you already use all three? Okay, I will delete the lowest score.